In this presentation, what we're going to do is learn how to calculate the mass of sodium hydroxide in a solution for which we do not know the amount of NaOH that was added to it. This is a titration that you guys have done in the past, but we have answered somewhat different questions about it. So this is super important that you know and understand how this works. So at the top of the diagram, I'm showing the reaction, the neutralization between hydrochloric acid and sodium hydroxide to produce water and a neutral salt. We have a known solution of hydrochloric acid whose molarity is 0.2 molar. This is the solution that is in the burette. And remember, from the laboratory, the burette holds a total of 50 mils of this solution. In the collection flask, we have X grams of NaOH. We have approximately 25 milliliters of the solution. And we have 4 drops of BTB. Remember that the solution starts out as dark blue and it ends up as green at the end point. At the end point, the point at which the reaction is over. End point, where the reaction is over. Now, to find the mass of NaOH that is in the solution, we are going to titrate this to the green point. So you are going to dispense hydrochloric acid out of the burette to the point where the solution turns green. At that point, you will turn off the burette, and then you will note the amount of hydrochloric acid solution which was dispensed. In this example, we're going to say that we dispensed 12.3 milliliters of the 0.2 molar hydrochloric acid solution to get to the end point of the reaction, the place where the reaction was over. Now, to find the mass, NaOH, first we start by taking the milliliters, and we have to convert this to liters because the units of molarity are moles per liter. So we're going to have 12.3 mils divided by 1,000 milliliters per liter. This is going to equal 0.0123 liters of 0.2 molar hydrochloric acid that was dispensed out of the burette. Now for the calculation. So we're going to start with the volume dispensed of the hydrochloric acid solution, 0.0123 liters. And we're going to multiply this times the molarity of the hydrochloric acid solution, which is 0.2 moles. HCl per liter. Now, you can clearly see that liters is going to cancel out. This is over 1. So we are going to have 0.00246 moles of hydrochloric acid that was reacted. Next, We multiply this times the fraction from the balanced equation. These are reacting in a ratio of 1 to 1. So it's going to be 1 NaOH over 1 hydrochloric acid. The HCl's cancel out, and we have 0.00246 mole of NaOH. Now, to find the grams, one last calculation. We have 0.00246 moles NaOH, and we multiply that times the molar mass, which is demonstrated for you up here at the top of the diagram. So this is going to be times 40 grams per mole of NaOH, and the total will be 0.0984 grams NaOH in the original solution. Note at this step here that moles cancels with moles, and that's how we got the grammage. Okay, with that, I'm going to conclude the video.